Hi, and welcome to my latest video, all about maths, estimating pi. I don't mean the pie that you eat. What we are going to do is obtain an estimation of pi using a strange method, by tossing needles. Let's see how it goes. Buffon's needles, an estimation of pi. This method is attributed to the well-known mathematician George-Louise Leclerc, otherwise known as Comte de Buffon, who, amongst other talents, developed a way of estimating pi using a probability method. Let's see how it developed. We will start by looking at a pair of parallel lines, 1 unit apart, and a needle of length exactly 1 unit, as you can see there. When we drop the needle, it could land, of course, either between the two parallel lines or anywhere else. We will use the center of the needle as our reference point. The length of the needle halfway is half a unit. We'll specify an angle theta in that right angled triangle, and using basic trigonometry, the opposite side to the angle is a half sine theta. What does that mean? It means that if a half sine theta is greater than a half, then the needle will fall on one of the two parallel lines. We can draw a graph of a half sine theta, and it's represented by the curve you can see there, and the area underneath will represent the chance or the probability that the fallen needle will land on a parallel line. So we can now establish our formula by working out the area under the curve, a half sine theta, and of its containing rectangle. That's what it will look like. We've shaded in the area under the curve, a half sine theta, and we also shaded in the rectangle. And of course, we will make the rectangle length pi units. So that means to work out the area in blue, the area under half sine theta, we can use integral calculus. We will integrate between the limits 0 and pi, and it turns out that the area comes out to be exactly 1 square unit. The area of the rectangle is easier to determine. It's just length times width. In other words, 0.5 or a half times pi, which is equal to pi on 2. So to work out an estimate for the proportion of the needles that land on a line, we can have the blue area divided by the area of the rectangle, which is 1 divided by pi on 2, and that simplifies to 2 over pi, and as a decimal and a fraction, we can write that as 0.63 or about 63%. That means that the chance of a needle falling on a line is about 63%. Rewriting our formula in terms of needles, we can write that the total number of needles on the line divided by the total number of needles is equal to 2 over pi. We can rearrange that to get pi by itself, in other words make pi the subject, and we end up having pi equals 2 times the total number of needles divided by the total number of needles on the line. And that's going to be our formula for estimating the value of pi. Let's look at this simulation program that I've developed to see the effect of using a different number of needles. Let's start with 10 needles. So with 10 needles, 8 of them have crossed over a parallel line, and the estimate using our formula is about 2.5. Remember, we're aiming for about 3.142. Let's try a different number. Let's try 1,000. The estimate this time, about 3.11. Getting closer, isn't it? Now I've tried more simulation with a great deal more needles, and this is what my results were. Here are some simulation results. I've tried different number of needles from 100,000 all the way up to 100 million. And as you can see there, we are accurate to 2 decimal places, 3.14, but going beyond that for accuracy seems to be a very difficult thing to do. Perhaps you can investigate this. I hope you've enjoyed this video. Please let me know what you think of it in the comments section and any suggestions for future videos. Until next time, bye bye.